This video will be talking about chemical analysis, both qualitative and quantitative, and is going through section 8.1 and a small portion of section 8.2 in the textbook. When we talk about chemical analysis, we're talking about analyzing an unknown chemical sample. We can analyze this unknown chemical sample either qualitatively or quantitatively. If we're doing it qualitatively, it means that what we're doing is we're identifying whether or not the substance is there. There's two main ways that we can qualitatively analyze something. The first way is called colorimetry. Colorimetry means that we're analyzing by color. We can either do that using a solution color test or a flame test, and we'll talk about both of those. In colorimetry, we're talking about either the light that is emitted, absorbed, or transmitted by a chemical. The next main way that we can do qualitative analysis is one that we've already covered and we talked about a lot in solutions. When we're doing precipitation reactions, what we can do is we can create double replacement reactions where both of the reactants are soluble. However, once the reaction happens, we have one product that is insoluble and creates a precipitate that we can filter out. In our solutions unit, we talked about using the solubility chart in order to do precipitation reactions. And what you're doing is you're looking on the solubility chart to find something that will create in the product a precipitant or something that is going to have a solid. So again, what we're using mostly for that is our solubility chart to find something that will be non-soluble or insoluble in water. When we're doing quantitative chemical analysis, what we're doing is we're determining the quantity of the substance that is present, which means we're trying to figure out how much of that substance is present. There's three main ways that we can do this. Again, the first way is colorimetry. Colorimetry, again, what we're doing is we're looking at the color, but we're assigning numbers to the color content. So we're talking about how much of that color is being emitted, absorbed, or transmitted. We're doing this through something called spectroscopy, and that means that we're using light and different instruments to determine how much of each color and which wavelengths of color are being produced. The second method is gravimetric analysis. And in gravimetric analysis, what we're doing is we're creating a precipitate. We are filtering it, which this word should say filter and not flitter, and then we are going to weigh. So we did some sort of this in our solutions unit, but in this unit we're going to talk about it using stoichiometry, which means we're using our mole ratios and our balanced chemical equation to predict how much product or how much reactant we need for a reaction. We'll be talking more about this in quiz 2. Our third type is titration analysis. And titration analysis again uses stoichiometry, which we'll be learning this unit, and we are going to use it to figure out volume and concentration of liquids. So that's something that we'll be dealing with in quiz 5. We're going to talk about two types of qualitative colorimetry. Again, this is finding out if something is present. What we can do here, in these different test tubes, I have 6 different solutions that are all emitting different colors. The question here, or the example, would be which solution is which. The colors of common aqueous ions, this is a chart that's found in your data booklet, so in your green booklet and on the yellow booklet that you'll have on every test. What I'd like you to try right now is press pause and match up which solution is which using the colors of common aqueous ions chart. Okay, so now that you've paused it, I'll go through the answers. Okay, so the first one says it has dichromate in it. Dichromate from this chart over here said it is going to produce an orange color. So I'm going to put an O down beside it for orange, and I imagine it is then going to be either number 4 or number 6 because both of them look slightly orangey in color. The second one says sodium chloride, and if you look down our list of common aqueous ions, you do not see sodium or chloride on that. What that means is neither of them are going to produce a solution color, and we are going to assume that it is colorless. I wrote down there colorless, and what that means is it is going to be solution number 2, because that's the only one without a color. The next one is sodium chromate, and you can see up here that chromate is going to produce a yellow color, so I'm going to put a Y beside it. And based on the dichromate above being orange, I'm going to say that the dichromate is going to be number 6. And I'm going to say that the chromate is going to be number 4. The next one says permanganate, and permanganate says a deep purple, so I'm going to give it a P. And the only one that is purple is going to be number 1. Nickel 2 nitrate, nickel says, and nickel 2 in particular, said it is going to be blue-green. And copper 2 sulfate, you can see that copper 2 is going to be blue. So with that, I am going to say that the blue one is going to be number 5, and the blue-green one is going to be number 3. Generally, what you'll see is all of these solutions are going to be paired up with a spectator ion that is not going to produce a solution color. Another type of qualitative colorimetry is a flame test. And this chart over here, the flame color of elements, is one that's also found in your data booklet. And you can see that there's some common flame colors of elements listed along with the color that they produce. This is how fireworks are produced in different colors. When a metal ion is heated, what happens is the heat is absorbed, and you can see that the black electron right here, once it gets heat, it is going to jump up an energy level and end up on a higher energy level. When the electron falls back down, the second part of the diagram, you can see that, again, the blue electron there is at the higher energy level. And when it falls back down, it's emitting light, and it's no longer thermally excited. And because it's no longer thermally excited, it's emitting that extra energy as visible light. Colorimetry can also be quantitatively measured, and that means we're measuring how much light. So you can see here that a spectrophotometer is the device that measures the quantity of light that is absorbed at any wavelength, which means we can measure it at any specific color. What happens is a light beam can be passed through a diffraction grating. And that diffraction grating right here, you would have talked about it in grade 9, and what it does is it splits up the color into its different wavelengths. And then we can adjust it so that we're only able to see one wavelength of light. We can then pass that certain wavelength, which in this example, red was chosen, through a sample, and we can detect how much of that color is actually getting through. What this will do is it will let us measure the concentration of any desired ion that we want, even if the solution has lots of different colors mixed up. This is what a spectrophotometer would actually look like. And this man right here is using an atomic absorption spectrophotometer, which is one that's used in a flame test. This slide includes some good practice questions that's talking about colorimetry.